We're going to look at the second type of log equation, which is type B, where all terms have logs in them. And what we mean by that is, if you look, there are three terms here, ln x minus 4, and then the third term is ln 3x. And every single one of these terms has a log in it, unlike the previous equations where there was a number without a log on the right-hand side. And this type of equation is actually easier to solve because we can make use of the property that if we have some log of base b of m equal to log base b of n, and they have the same base, that then the two interiors, m and n, will just be equal to each other. So first thing we need to do is get our two log terms put together into one, just like before. Because the two separated log terms are added, the interiors will be a product. So we've got x times x minus 4 on the inside on the left, and then this will just be equal to natural log of 3x. Now, our interiors will be set equal to each other, so we're just going to say x times x minus 4, which will give us x squared minus 4x, is equal to what's on the right-hand side, which is 3x. And if I subtract off the 3x, I end up with x squared minus 7x is equal to 0 on the right, and I can factor out the x. I get x times x minus 7 equals 0. So our two solutions are that either x is going to be equal to 0 from the first factor or positive 7 from the second factor. Just like before, we'll go back and check. So checking our first solution, x equals 0, I put it into the original equation and I can see problems here. ln of 0, that again is going to give us something undefined, so we need to eliminate this solution. But if we check the second solution, check x is equal to 7, then I have natural log of 7 plus natural log of 7 minus 4 gives us 3, and we ask, is that equal to natural log of 3 times 7 is 21? And if we test it out, putting the two logs together, natural log of 7 times 3, that does give us natural log of 21, and therefore this is a good solution, and we have checked it. Let's take a look at an application, and this actually has to do with exponent equations, but we will use logs to calculate the inverse of that exponent. So looking at the problem, it says research indicates that the risk, which is represented by R, the risk of having a car accident increases exponentially as the concentration of alcohol. So we're asked, what blood alcohol concentration, that's what we're trying to find, corresponds to a 20% risk of a car accident. Here we're told that R is a percent, and so we will not convert this to decimal, we will just put 20 in for R. But then the rest of the equation says 20 is equal to 6 e to the 12.77 times x, and this x again is that concentration that we are asked to find. And x is up in the air and I want to bring it down to the ground, so I'll need to take the log of both sides. But before I do that, I want to isolate the base, which is e, so I'll have to divide both sides by 6. And then I end up with 10/3 is equal to e raised to the power 12.77x. Now if I want to eliminate that base, I'll need to take the natural log of both sides, natural log on the left, natural log on the right, and remember, natural log and e to the power are inverses, so those will disappear. And I just get then that 12.77x, which is on the right, is equal to natural log of 10/3. Using a calculator, that natural log comes out to be about 1.204. So when I want to solve for x, I have 12.77x is approximately this decimal value, and dividing by 12.77 on both sides, I get that x is equal to approximately 0.094. Now when you stop and think a minute, the legal limit of blood alcohol concentration for driving is 0.08, which is lower than this value. And again, this corresponds to a 20% risk of having a car accident. So 0.08 is slightly less than that, but not that substantially less. So when you drive at the legal limit, you still have a fairly substantial risk. Now let's ask the question, what blood alcohol concentration corresponds to a near certainty of a car accident? And in this case, the phrase near certainty implies 100%, or pretty close to it. So we are now going to substitute this for R, the percent of risk. So if we plug it back into this equation up here, we've got 100 is equal to 6 e to the 12.77x, and again dividing by 6 to isolate the exponent, we will get then that e to the 12.77 is equal to 100 over 6. And when we take the natural log of both sides, we will end up with 2.813. And from here we want to again isolate that x, so the natural log and the e will cancel, and we get 12.77x is equal to this decimal 2.813, and dividing both sides by the 12.77, we are going to end up with about 0.22. And again, the legal limit, it's about 0.08, so we are nearly triple the legal limit and having, again, a near certain chance of having an accident.